Hey everybody, this is Dave, week 4, I don't know, of the Leetcode weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. 305, number of islands 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Alright, so you have an grid M by N. I hate this M by N. Why don't people just standardize with R and C? And they do use RNC kind of, so I don't know. It's a little bit weird. All right. Okay, so we may add land, which turns a water into an. Oh, okay. What are we doing? Oh, so this is a move by move thing. You want to return the number of islands at every time. Okay. Okay. What is this? Log M. What is the slower way of doing it? I mean, so the way that I'm thinking about it is just union find, right? Union find seems pretty okay, right? Then now you can figure how do you get the count? Oh, because when you add a new one, then it either creates a new island or it doesn't. Okay, that makes sense. Is that true? So when you add a new item, no, that's okay. I see it. I think it is possibly tricky to maintain, but this is just a union find problem. Basically, the thing that union find is good for is this dynamic adding thing, right? And this is connected components. We've been talking about connected components the last couple of days here on the channel. So it should not be surprised that it is union find, right? And so I would say that previously we have said that for connected components, you can usually solve it as well with depth first search and breadth first search. The reason why we cannot do it here is that this is in a way a sort of a live interactive thing where you have to get the answer for every intermediate step, right? And because of that, you need a different data structure to allow you to make these incremental order dependent operations versus like a static thing, right? All right. So without further ado, let's type union find. The thing that I want to do here is that we have a 2D union find, but that's fine, right? Because you can reduce a 2D union find to a 1D union find if you like. I'm not gonna go over all the math, but you could just say, like, for example, this is all. I'm gonna rename this R and C just because this is silly. But right, you can. For example, you have a union find from, say, a 2D union find from 0, 0 to R minus 1, C minus 1, I think, right? Let's see if they're 1 indexed or 0 indexed, right? So yeah, so something like this, but you can also just map this as like, from a 2D matrix into a 1D array, right? Like you can just go from, instead of saying 0, 1, 2, 3, 4, okay, so now for a 5 by 5 matrix, instead of going 0, 0, 0, 0, 0, 1, 0, 2, 0, 3, right? All right, let me just type it out real quick. Oops. Something like that, right? And of course, the second row, you have 1, 0, dot, dot, dot. I'm too lazy to fill it out. You could just remap this to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, dot, 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 right? And this is a very, a base C number. Yeah, base C number, right? So now now of course you can convert this, and that's how you would do it with your union find. As an example, I mean, you don't have to do it this way anyway, and I'm not going to actually. Instead, I'm just going to use it with a set. And if you watch my channel enough, in general, I do not have templates. I do not use any of them. It's mostly 99% true. The only thing that I do have a template for is segment tree, but even then I don't know. I'm a little bit debating about that. And the trick is not to memorize how to implement it. Because if you're memorizing it, then it is a template anyway, whether you paste it in or type it in. The idea for me is just that I like to remember the concepts that I need, and then everything just kind of falls through usually. That said, of course, for competition it's a little bit tricky because because not using a template is two times bad, right? Because one, you're spending time on typing it in. Two, it's very easy to make a mistake on a typo or something like this. And I've done both of these things many times, so definitely buyer beware. But I would also say, focus on what you want to get better at, right? I mean, hopefully you've watched my other channel. I talk about goals and things like that. At the end of the day, competition is like, okay, if you're on site or something like this, like a competition with implications, right? Like if I was at a Google Code Jam or something, and I'm if I do well, I get to be a finalist or something like this, right? Of course, I'm going to use all the templates, right? I'm trying to maximize what I have, and then maximize the output of what I already put in, right? But if you're just like learning and you're trying to focus on playing with the little things and the nuances and the tricks things, like, why does it matter that you solve the problem 5 minutes slower, right? Doesn't really matter. Like, yeah, your rating will go up, but does it matter? What is I don't know. If you ask me, I don't think so. Anyway, that's my philosophy on templates. We could talk about it another time, but yeah. So then here, instead of saying an item, I write it with XY, and then I just kind of write keys, and I just do this for a tuple. Sometimes I write it differently, so don't hold me to it, right? Yep, not in parents. Don't know how the T went like 4 spaces there. Yeah. And this is general union find stuff. Just to be clear, I am not going to go over union find in this video. Maybe I should type it up though. Or this you see as DSU, which is disjoint set union. Alright. Alright. And now maybe I would write x1 y1 x2 y2. Oops. Right. And yeah, you should be able. This is pretty fundamental. You should probably know a good amount of it. So definitely check it out on the YouTubes. I'm not going to go over in detail here just because I've done it already, and also I don't know how many videos of union find you need to find, right? Anyway, and now I have a union function, right? And I have key 1 is equal to x1 y1, key 2 is equal to x2 y2, right? And then now yeah, you find of key 1 is going to be, say, parents of 1. P2 is going to be find key 2, right? Ooh, this is a little bit awkward now that I think about the usage, but okay, fine, it's too late, maybe. Like I said, I don't memorize these templates. So yeah. So then now parents of P1 is equal to P2, right? I guess we don't need this then. And so when people talk about path compression, this is the path compression. And that's all I do. You can also do a union by size or rank, or there are a couple of things you can do. For me, I don't find it usually matter, and in theory, it gets the constant time a little bit faster, but I don't pay attention to it. For the most part, I have not seen it to matter. There are some tricky things about, like, small integrator if you want to be really specific about certain things, but I'm not gonna get into it here. It probably shouldn't matter. If it does, we'll come back to it. But it's just, yeah, one fewer complication to worry about. Anyway, then now we get to the query, right? For x, y, and positions, right? So then now here we have islands is equal to 0, and maybe we have an answer is right? And now we have to be really careful. All right, so here, oh, and we have to look up, we have to add the directions, right? So directions is just up, down, left, right, right? So I think about it as dx, dy, so I just kind of get all the diagonal, or not diagonals, literally like all the cardinal directions is what I meant to say, right? And then now here, so now we're adding this position. What does that mean? That means that we're adding a new island. We want to join it with the up, down, left, right? So then now islands is we increment by 1, because in this new position, assuming that we do duplicate positions, does it say? Huh. Actually, I don't think it's not clear. We might have to do another other thing. For now, I'm gonna assume that it is always from 0 to 1. If they kind of repeat the query multiple times, then we'll just be annoyed and like be like, come on, friends, why are you doing this? Maybe we can even do this, right? Like we'll see if they complain. Okay. Return, right? What? Oh, right. Okay, so it seems like this is valid input, which is okay, fine. So that we have to just keep track along. I mean, that is very silly actually, but okay, fine. So then now, oh, it's not silly. It's just like an additional if statement. But yeah, and we don't do this if xy is in scene, then continue, because then we don't do anything. Well, I mean, we have to answer that append islands, and then we continue. Otherwise, scene.add xy, and then now we have a new island. Except for that, now we have to look up, down, left, right? And the logic here is just going through all the cases. Is that okay? Right, and then we have new for dx, dy in directions, right? Nx and y is equal to x plus dx, y plus dy. This is just going up, down, left, right. And then now, if but make sure that it is within bounds, of course. If this is the case, then now what? Okay, well, if this is in scene, that means that this is an island, right? Then we want to union it, right? But before we union it, we want to see if we're already part of the same island. So if you find of xy is equal to you find of nx and y, if they are already the part of the same islands, then we don't do anything, right? So we could continue. Otherwise, if they're different, then that means that we now combine one island. So that means that we no longer I mean, I think you need to visualize this by drawing it out. I don't think I need to draw it out, because I feel like this is, you know, you could pause and then draw it out. But the idea is that, okay, let's say you have a new island coming up, and then if it's connected to that island, then this is not really a new island, right? And that island, so then now we can do, so if they're different, that island we decrease by 1, and then we union them together, right? And that's pretty much it. And then at the end, we append islands, and that should be good. Yeah. All right, well, islands, is it? Let's give it a quick submit. Hopefully I didn't make a silly, oh. Did I miss something? How did that happen? But yeah, speaking of templates, how did that, oh, that is lazy. Okay, fine. Huh. And this is why you have templates, for example, for a live contest. But here, it's a good practice. I never know how to write this quite succinctly. And it bit me that time with a silly typo. But yeah, as you can see, very easy to make a mistake when you don't have a template. But I mean, that's fine. We're learning, and I'm here trying to figure out, it's an easy way to easy thing to learn, easy debug, and so forth. What is K? K is the link. I mean, basically, what we have here now is union find, right? And because of path compression, this is better than log, I think. So yeah. So the follow-up doesn't really apply because the complexity here is that we do at most 4 union finds, right? Up, down, left, right. Everything is just seen. Island, this loop is only over 4, right? So yeah, so this is going to be linear in the size of the positions, which is the size of the input. And in terms of space, this is also linear because we can only add one thing to scene and parents to the union find only once per position. So we don't have anything dependent on R and C. Everything is just that, right? So pretty straightforward, pretty cool, pretty good. So yeah, that's all I have for this one. Let me know what you think. Here's my union find code. As you saw, I did it live, so you can copy it and play around with it, but learn it, not just use it, right? And here's the kind of just like a pretty straightforward up, down, left, right check. I think the biggest part about this is just this island invariant thing, and what happens if they're already or either they are or they're not as part of the same land mass or island mass or whatever. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.